Let us look at proposition number 26 of book 10 of Euclid's Elements. The proposition says a medial area does not exceed a medial area by a rational area. So basically what this means is that from a given medial area, if we subtract another medial area, so this green color area is another medial. So from medial area AB, if we subtract medial area AC, then the remainder cannot be a rational area. So that is what this proposition means. So let's see how we can prove this. Given two medial areas AB and AC, if possible, let AB exceed AC by a rational area DB. So here we are basically assuming the opposite, that DB is the rational area which we get after subtracting AC from AB. We set out a rational straight line FE. So we have drawn a rational straight line. Apply a rectangular area FH equal to AB. So FH here is equal to AB. Subtract the rectangular area FG equal to AC. So remainder KH equals the rectangle DB. That is pretty clear. AB is equal to FH. AC is equal to FG, means DB is equal to KH. DB is rational. So which means KH has to be rational also. FG and FH. FG and FH are medial. Why? Because they are equal to AB and AC, and those are medial. FG and FH are applied to rational straight line FE. This is a rational straight line. So EH and EG, EH and EG are rational and incommensurable in length with EF. So EG, EH are incommensurable with FE. KH is rational and applied to a rational straight line FE. KH. Of course, it has been applied to KG, but remember KG is equal to FE. So we can say KH is rational and applied to a rational straight line FE. Now GH is rational and commensurable in length with FE. GH is rational and commensurable with FE. Why? Because KH is rational and it is applied to a rational line FE. So that means the other side of that rectangle will also be rational. Now EG is incommensurable in length with GH. EG is to GH. EG is to GH as EG square is to EG by GH. That means EG square is incommensurable to the rectangle EG by GH. Why? Because EG is to GH. If you look at this, EG is incommensurable in length with GH. So if these two are incommensurable, then these two are also incommensurable. But EG square and GH square are commensurable with EG square. EG square is commensurable with itself. Now EG and GH, although they are incommensurable in length, they are commensurable in squares. So we can say they are commensurable in square only. Also, 2 times EG by GH is commensurable with EG by GH. This is just a multiple of this. So it will be commensurable. EG square plus GH square is incommensurable with 2 times EG by GH. G square plus GH square is commensurable with EG square. 2 times EG by GH is commensurable with EG by GH. But here in all this, EG square is incommensurable to the rectangle EG by GH. So that means EG square plus GH square is incommensurable with 2 times EG by GH, because EG square is incommensurable with EG by EG square plus GH square plus 2 times EG by GH is equal to EH square. Now, how did we get this? EG square plus GH square plus 2 times EG by GH is equal to the square on EH. I'm sure if I say it in today's language, immediately you will catch it. What is that? A plus B the whole square is equal to A square plus B square plus 2AB. Yes, basically we did all this to get to this. Okay, but remember EH square is the square on EH, and this expression is equal to EH square. So EH square is incommensurable with EG square plus GH square, because EG square plus GH square is incommensurable with this. That means EH square is incommensurable with EG square plus GH square. Since EG square and GH square are rational, because EG and GH are rational, EG and EH are rational. So, which means the squares will also be rational. So, since EG square and GH square are rational, EH square is going to be irrational because it is incommensurable. So, if a rational number is incommensurable with another number, then that number is going to be irrational. Okay, so EH square is irrational, which means its side will also be irrational. Now we have reached a contradiction. Since EH was rational, say here EH and EG are rational and incommensurable with length with EF. So EH is rational here, and here we have reached a conclusion that EH is irrational. So it can't be both. It can't be rational and irrational. So that means our original assumption was wrong. And what was the original assumption? That AB exceeds AC by a rational area dB. Since our assumption was wrong, means dB is not a rational area. dB is an irrational area. So which means medial area does not exceed a medial area by a rational area. So that is proposition number 26 of book 10 of Euclid's Elements. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now.